Geometry, Unit 4, which is from Chapter 9 of the book, Section 5, Distance in Coordinate Geometry. Distance on a coordinate plane. So the distance of a coordinate plane can be calculated using Pythagorean theorem. This can be done by looking at the x and y distances to create a right triangle. So in this problem, we can see we've got a distance of 8 and then a distance of 4. So that's a right triangle. And so we can do Pythagorean theorem. 4 squared plus 8 squared equals c squared. So 16 plus 64 is c squared. So c ends up being the square root of 80. And let's go ahead and let's simplify that. We know that's 5 and 16. 16 reduces to 4, square root of 5. All right, so let's do this one. We got a distance of 9 down, distance of 10 over. So 9 squared plus 10 squared equals c squared. Hypotenuse is c. So 81 plus 100 equals c squared. So c is the square root of 181, which I cannot simplify that. The distance formula is actually created from the Pythagorean theorem, which is what we were doing back here. We were doing the distance formula. We were doing Pythagorean theorem. Now what we're going to do is we're going to create the distance formula from the Pythagorean theorem. So a squared plus b squared equals c squared. Well, a is just created from the difference of the x values, and b is just created from the difference of the y values. So this is where the distance formula comes from. The square root of the x differences squared plus the y differences squared. So let's find the difference between a and b. So then we'll call this x1, y1, x2, y2. So the distance formula, the square root of x1 minus x2 squared plus y1 minus y2 squared. So negative 5 minus 13 is negative 18. 12 minus 22 is negative 10. Remember, when you square any numbers, the negatives go away. So negative 18 times negative 18. We end up with 324 plus 100. So we get the square root of 424. If I take a 4 out, I get 2 square root of 106. So that's how we apply the Pythagorean theorem using the distance formula. All right, let's do some more problems with radicals, and what we're going to do is we're going to rationalize the denominator. We do not want radicals on our denominator, and so to rationalize them, what we do is we multiply by the radical to the top and bottom. Square root of 5 divided by square root of 5 is really timesing by 1, so it doesn't actually change anything, but I get rid of the radical on the denominator. So I get 4 square root of 5 divided by 5. All right, so let's do this one. So let's multiply square root of 6 times square root of 6. I get 3 square root of 6 over square root over 6. Now I can simplify this more because 3 divided by 6 ends up being 1 over 2. So square root of 6 over 2. Let's look at this next problem. So let's times by the square root of 12. So I end up with 3 square root of 12 over, that's 12, so 4 times 12 is 48. So let's simplify that. That gives us square root of 12 over 16. Same problem, just I added that square root of 2 on the top. So I'll start the same way and multiply by the radical on the denominator. So I get 3 square root of 24 over 48. So I know that gives me square root of 24 over 48, but I'm not done because I can simplify that square root of 24. Square root of 24, I can simplify. Oh, I'm sorry, that should be a 16 there. Square root of 24, I know can simplify to 2 square root of 6 over 16, and I get square root of 6 over 8. And there we go. And that is the end of this lesson.